So, good morning students. Now I am going to do 10th state Cbse Pythagoras theoretical problems. So, we will be finishing within soon this chapter. What is given? Triangle ABC is an isosceles. Triangle ABC is an isosceles triangle whose base BC is internally divided. Base BC is internally divided at the point Y. Internally at the point Y. Prove that they are asking this one. So, triangle ABC is an isosceles triangle, and what is given? Whose base is internally divided at the point Y. So, that is the meaning of this question. Internally divided means not outside. Internally means, internal means inside the triangle ABC, you mark the point Y, and there you have to prove this one. So, for this, construction is required. Draw AM perpendicular to BC. Therefore, triangle AMB is congruent to triangle AMC because by RHS property, right angle, hypotenuse, common side. By RHS property, the triangles are congruent. You have to write all the steps. AB is equal to AC, isosceles triangle, angle AMB 90 degrees, angle AMC 90 degrees, and AM is equal to AM common. Therefore, by RHS property. Since you are in 10th class, I am not writing all the steps, just I am explaining orally. Please write down by yourself. Therefore, triangle AMB is congruent to triangle AMC. From this, again, here, if you consider this one, this is 90 degrees, no? So, obviously this angle is acute, right? So, angle AMC is equal to 90 degrees. Also, angle C is acute, right? So, apply Pythagoras theorem for this triangle AMC. Consider triangle AMC, or you can consider triangle ACB also. ACB. Consider triangle ACB. Now consider triangle ACY. I'm sorry, consider triangle ACY. This triangle ACY, because this is right angle, so I want to consider this triangle ACY. Apply that Pythagoras theorem. AY square is equal to, since angle C is acute, what can you say? AY square is equal to, see here we are coming to the near to the theorem. AY square is equal to YC square plus AC square minus twice the length of this one, CY into CM, right? So now AY square is equal to AC square. See here, AC square I am writing as it is. Here YC is there, YC is there. Take YC as common or CY as common. CY into CY square minus 2. Already we took CY outside, so it will remain 2CM will remain, right? Therefore, AY square is equal to AC square plus CY into CY minus 2CM. So, we have proved the triangle, these two triangles earlier, we have proved that this triangle is congruent to this one. Therefore, you can write here, therefore, CM is equal to MB. CM length is nothing but MB length. So, CM is nothing but 2CM is nothing but CM length. How will you get? Is nothing but what you will write here. 2CM is nothing but BM. 2CM is nothing but BM. 2 into CM. is nothing but, I'm sorry, BC. 2 into Cm. 2 into Cm is nothing but what I am saying is complete length BC. See here I will draw the sub-diagram. BC and here M is the, so Cm is equal to MB. Cm is equal to MB. Suppose if this is 3, this is also 3. So Cm length, what I am saying is Cm length is 3. Cm length is 3. So 2 into 3. You see here 2 into Cm. 2 into Cm length is 3 now. Here 2 Cm is nothing but 6. But what is 6 is nothing but BC. 3 plus 3 is 6. So BC length is 6. Just I took an example so that you will have a clear picture and you can understand from this. So AC square plus CY minus BC. CY here minus is there, no? So take minus common here. So what you do is take minus common here. Take minus common here. AC square plus or minus CY BC minus CY. This can be also written as like this. AC square minus CY into BC. Already it is there, no? So minus into minus is plus CY square. CY into CY is CY square. So AC square minus CY into BC minus CY. BC minus CY. Complete length minus CY is nothing but BY. So once again, see here BC minus CY. BC, again I will draw the diagram for you. BC, here it is Y. BC minus CY is nothing but BY, no? This complete length minus this length. BC minus CY. BC minus CY is nothing but BY. So in place of this I have written BY. So AC square minus BY into CY. BY into CY. That's it. Very easy and nothing confusion in this problem. Therefore you need to apply this triangle you have to consider and acute angle. This AY square is equal to AC square plus CY square. AC square plus minus 2 times this CY into MC. This is by theorem. You can write here by theorem. By theorem. So I took CY common. So AC square as it is I written CY into CY square minus 2CM. Next 2CM is nothing but just now I explained this one CY. So BC is nothing but CY. Again see what we have to prove. AC square minus BY into CY. So here I need to take minus common. Otherwise I cannot arrive to this theorem, to this conclusion. Minus CY I took outside. Minus CY into BC minus CY BC. Right. Next minus into minus is plus CY into CY square. But BC minus CY is nothing but BY. So therefore AC square minus BY into CY. There ends the problem. This is another important method. Because already we did this problem by external. Point Y is lying internal, no? Therefore in that one of the problem I did point Y is lying external. Right. Another question. ABC is a triangle and G is the centroid. Prove that G is the centroid, ABC is the triangle. They have given AB square plus BC square plus AC square is equal to 3 times AG square plus BG square plus GC square CG square. So here ABC is a triangle in which G is the centroid. AB is a triangle in which G is the centroid. So we are asked to prove that AB square plus BC square plus AC square is equal to 3 times AG square plus BG square plus AG square. So before doing this problem, you should know that centroid divides the median in the ratio 3:1. So D of something. Centroid divides the median in the ratio 3:1. So AG is equal to 2 by 3. AG is this length. 2:1 I told no. 2 by 3 of AD. Right? AG is equal to 2 by 3. AG length how will you get? 2/3 of AD. Therefore, now similarly, BG is equal to 2 by 3rd of BE. Similarly, CG is equal to 2/3 of BF. Right? Now, what you have to do is, by previous problem, just now some time back we have done equilateral triangle, something like that. Prove that 3 times the sum of the squares of sides of a triangle is equal to. We have already proved that 3 times the sum of squares of the sides of triangle AB square plus BC square plus AB BC AC is equal to. Prove that 3 times the sum of squares of triangle is equal to 4 times the sum of the squares of the medians of the triangle. This we have already proved. 4 times. See previous videos of my problem. Please you can refer that. Is equal to. Prove that 3 times the sum of squares of the triangle is equal to 4 times the sum of squares of the medians of a triangle is equal to 4 times medians of triangle. AD square plus B square plus CF square. Right? So therefore, from this 4 AD length is nothing but, from this what is AD length? 3 by 2 AG square. Right? This AD length, see here, cross multiplication, 3 by 2 times AG square plus same thing 4 times. This you have to write by yourself, since we have proved that, or else if they give this problem in examination, you should completely write the previous problem, then only you have to proceed. Don't write here from previous theorem like that, from previous problem, they will cut the marks. What you have to do is, since I have done already in the previous video, that's why I am writing directly this step. But in examination, if they give this one, you have to prove that also. That problem of this one also you have to prove it. Therefore, is equal to 4 times AD. AD is nothing but, from this AD is equal to what? 3 by 2 AG. Right? AD square is equal to 9 by 4 AG square. So I am writing AD square 4 into 9 by 4 AG square directly, plus 9 by 4 BE square. 9 by 4 B is nothing but BG square, plus 9 by 4 into CF. This is not CF. 9 by 4 CF, what you will get? 9 by 4 into CG square. So take 9 by 4 common outside. 9 by 4 already 4 is there. AG square plus BG square plus CG square. So 4 gets cancelled. 9 AG square plus BG square plus CG square. Here already we got 3 times AB square. This is LHS. AB square plus BC square plus AC square. 3 ones are 3. So AB square plus BC square plus AC square is equal to 3 times AG square plus BG square plus CG square. Therefore, hence the problem. So these typical problems we have completed. Thank you students, have a nice day. Please don't forget to click on the blue color icon button and subscribe my channel. Thank you very much, have a nice day. Bye.